In the previous video, we created an eye tracking folder under the username date created folder, and we saved data from the eye tracker. Usually in research projects, we are also interested to see where the user has looked and for how long the user has looked at a specific object in the screen. So I also wanted to include that. So what I want to do now is to save data whenever the user is looking at a specific object in the screen. And we can save the data in a CSV file as well. So let's go to Unity. And here in Unity, I'm interested that under this chemistry lab studies, so we can go ahead and disable this practice trial, and we can enable the study. I want to do that whenever the user looks at these instructions, we can save data every time the user has looked the instructions and for how long. And we also can save data for how long the user has looked at the game objects for the models for the experiments and for how long. So first we need to enable for now this gaze tracker game object. And if we open, we can see here under the gaze controller that there is a gaze visualizer. And if we enable this gaze visualizer, it will show a gaze model here. So this gaze visualizer, what this gaze visualizer does is that it shows in screen where the user is looking. So we do not want to show where this model of the gaze here in the screen. So we can just go to raycast hit marker, and this will be just a marker of the pupil where the user is looking in the screen. We want to set this as cutout, and I want to set the alpha cutout as 1, and this here should be set to transparent, so the user do not see this model here. And under this raw gaze direction, we can do the same. So we need to set this as cutout, set the alpha cutoff as 1, and set this to transparent. So this way we are going to use this gaze visualizer. So we need to enable this in the screen, but we do not show the model, so where the user is looking. Under this gaze visualizer, we also want to attach the camera of the player VR, so we can attach the camera here. And we want to set this as 1, and we want to set this as 0.1. And we want to check this binocular only, and save. And now we want to open this gaze visualizer code, C# script. And here we want to change this as well to be 1.0 for the confidence threshold. Well, this confidence threshold means that the higher this confidence threshold, the better and more correct data from the eyes we have. So this should be set to 1. Binocular should be set to true. And this one should be set to 0.1. So if we go here, we have this 0.1, so we can copy it, and we can set this to 0.1, and this is all done, so we can just close that C# script. And now we want to create a new C# script. So let's go to our scripts folder and just create a C# script, and we can call this on collision eye. In this collision eye, what I want to do is to get the eyes from the gaze visualizer here, so the raycast hit and the ray gaze direction. And I want to make a check that whenever the user is looking at the collider of the instructions, then we need to save data. So let's just go to the Canvas robot instructions, and under this information here, we can create a box collider. So box collider, and we need to edit this collider. So let's just edit around the instructions. Let's have a look. We can also include this. And it seems that the collider has been set correctly. Press save. And now under this collider, we want to add a tag. So add tag. And we can call this instructions. And press save. And let's not forget to add the tag here, instructions. And we can do the same for the models, for the experiments. So if we can just enable this model here, we can see that we can put a collider here for the models. If we enable here, we put a collider somewhere here. So let's just create a game object here. And we can call this collider experiments. And we have to attach a box collider. Let's just get the values from this experiment 1, or we can just get the baker here, the values from this, copy component, and paste the component values. And let's just change, let's edit the collider. To be somewhere in front of the user. Let's go to the collider. Let's just collapse that. And the collider will be somewhere here. Just edit the collider a little bit further. So in this area here, we will show the experiments. So the collider is here, as you can see. So let's open experiment 2. The collider is here. So I think the position of the collider is correct. And just make the final changes to be somewhere here. Now let's disable this experiment 2, enable experiment 3, and the collider is here. So it seems the collider has been set correctly. Now let's add a tag for the experiment collider. You can call this all experiments. All experiments. And we need to add the tag all experiments. So what I'm doing here is that I set 2 colliders for the experiments and another. So I set 1 collider for experiments and 1 colliders for the instructions. And I add the tag here, and I want now to check that if the user is looking at the instructions, I want to save in a CSV file all the timestamps where the user has been looking at the instructions, and in another CSV file all the times that the user has been looking at the colliders. So we can just save that. We can disable this game object now. And we can disable this game object. And let's enable the chemistry lab practice game object. Now we need to create a C# script and just go to create. And I think we actually have created the OnCollision eye, so let's go ahead and open. And for this collision eye, we need to use first using Pupil Labs, using system, using Unity engine.ui, and using system.io. In the beginning here, I want to first initialize a public gaze visualizer, and we can call this gaze visualizer. Another public gaze data, and we can call this gaze data. Now we need to get public transform gaze origin camera, so we need to get the camera. And we also need a public gaze controller. That we can call this gaze controller. So I'm getting all this information from the Pupil Labs. And now in start we can delete this. We don't need this. We need to create a public or private void on enable. So we can use this function here on enable, and we need to make a check that if gaze controller, it should be here, if gaze controller, and we need to say gaze controller dot on receive 3D gaze. So we are getting the 3D gaze from the gaze controller. And we need to create a function here that we can call on receive and now we have to create this function on receive. So we can just say private void on receive gaze data. We need to return something. So we are receiving all the gaze data from the Pupil Labs here. Afterwards, we can now go to our update function and we can say if gaze data is not equals to null, then we need to get all the information for the gaze data, so where the user has been looking or where the user will look. So to do that, we need to initialize a vector3 origin, get the gaze origin position from the camera, and now we need to initialize another vector3 for direction. Gaze data dot gaze direction should be. And now we need to check that if the physics.sphere cast origin 0.1f, raycast hit. So here we are getting the gaze information, so where the gaze is looking, using the raycast hit. And now we need to make a check that if hit that collider, that tag is equals to instructions. So if the user is looking at the instructions collider that we actually named it, and we put a tag of instructions, then we can call for a function that we can say looked at instructions. And we need to create this function. And you can just copy this. If hit.collider.tag is all experiments, so if we go to Unity, this collider experiments has all experiments tag, and this canvas robot instructions has the instructions tag. So this is what we are doing. We are just checking if the user is looking at the instructions, and we will create a function for that, or if user is looking at all experiments. So under those two functions, we want to save data. So let's go ahead and create the function. You can call this, just copy it. And we can also create this function looked at experiments. And now, similar to what we did here in user form, we need to create a date. So to get the date here. And you also want to create a path. For the path, we can get this path here, because we want to save this CSV file under the eye tracking folder. So we can just say string path is equals to this eye tracking folder. And for this user group and username, we need to use the scene data. And again, the scene data for the username. And after this eye tracking folder here, we want to say plus and create a looked at instructions.csv file. And press save. Now what we want to do is that we want to include into the CSV file the Unity timestamp and Pupil timestamp. And if we go to Unity and if we go to the time since game object here, we have a time since. So let's go ahead and open that. And this time since has a double Pupil time and a double Unity time. So on collision eye script, we need to use the time since script. So then we can get those two. Let's go back to our script. We can just paste those. And now what we need to do is that we need to check that if the file does not exist, similar to what we did for the user's demographics CSV file. Then we need to include the headers. And we can say here Pupil timestamp Unity time. and looked at. And here we need to append the environment dot new line. And file dot append all text path header. Now we also want to add the values that we can set as pupil time and unity time. Here we can also say instructions. And afterwards, we need to also append the environment dot new line. And this instruction should be as a text. And let's not forget to append all text. Append all text, path, and values. Similar to what we did here, we need to do the same here. So let's copy and paste here. And here we need to change to all to experiments models. And we need to change the CSV file looked at experiments models. And everything else should be fine. Those are all correct. So now let's go ahead and save. Let's go back to Unity, and we need to attach the onCollisionEye script into our case tracker, case controller here. So let's open our scripts and onCollisionEye. So let's enable this game object for now. And under this, under the under this here, we can attach the onCollisionEye, and we need to include all. So for the request control, connection, for the gaze visualizer, gaze origin camera should be the camera here of the VR, and for the gaze controller, and everything it's set to correct. So now we can just disable this game object here, because the user first needs to complete the lab practice, and then needs to do the calibration, and then we can record the data. So we can test this in the next video.